Good day to you. We have seen boost converter and buck converter in the previous videos. In this video, we are going to see about hash bridge. This is more popularly and widely used circuit in power conversion. There are so many applications for this one. Inverters, UPS, SMPS, and then there are so many applications for this circuit. So we will see this in detail in this video. This is Kadal Amudam from Chennai. A hash bridge consists of four devices mainly. Device 1, 2, 3, 4. The device can be a MOSFET or an IGBT, and then every device has a freewheeling diode in anti-parallel connection. Diodes are required to conduct in the freewheeling energy. So the switching sequence is device 1 and 2 will be switched on simultaneously, and then after some time device 3 and 4 will be switched on, and this will be alternated. At no point of time you can switch on both 1 and 4 simultaneously. Similarly, you cannot switch on 3 and 2 simultaneously. This will result excessive current through both the devices and it will damage the device. So after switching off 1 and 2, you should give a small gap of 5 to 10 microsecond, and then you shall switch on 3 and 4, and then after switching off 3 and 4 you shall give a small gap of 5 to 10 microsecond and then switch on 1 and 2. This gap is called dead band, where all the four switches will be off. We will see the current flow diagram. Current flows from the source to Q1 and then through load and then through Q4 and goes to the ground. In the other direction, current flows from the source to Q3 load and then Q2 then ground. You can see that current flows in opposite directions alternatively. So this is conversion of conversion of DC into AC. So this is the main purpose of the circuit. DC will be converted into AC or square waveform in this circuitry. This is the simplified waveform of hash bridge. This is one of the uses. AC has been converted into DC has been converted into square wave AC waveform. This is a little bit more complicated switching waveform. Device 1 and 2 will be switched on and off for some time, and then device 3 and 4 will be switched on and off for some time. So the purpose of waveform will be clear from the next slide. This image gives a detailed waveform of the PWM switches. This is called sine weighted PWM. This kind of switching generates near sine wave AC waveform and AC current. This is widely used in UPS applications. This is the end of this video. Kindly subscribe to the channel so that you can watch more videos in the coming days. Thank you for watching. This is Kadal Amudam from Chennai signing off. Good day to you.